Okay, now we will discuss the determinants of glomerular filtration rate. So, the determinants are the sum of the hydrostatic and colloid osmotic forces which act along the glomerular membrane. And the second factor which determines the glomerular filtration rate is the value of the exponent Kf. Expressed mathematically, this formula will be as GFR is equals to Kf multiplied by net filtration pressure. So the net filtration pressure depends upon four things. First of all, here as you can see, this is the glomerular capillary and this is the Bowman's capsule. The four determinants of net filtration pressure are glomerular hydrostatic pressure, which is about 60 millimeter Hg, and it increases the GFR. If we increase glomerular hydrostatic pressure, GFR will also increase. The second factor is glomerular osmotic pressure, which is due to the presence of plasma proteins and other types of proteins. It opposes the GFR. It means that if the glomerular osmotic pressure is high, the filtration will be low. Its normal value is 32 mm Hg, and the Bowman's capsule hydrostatic pressure is 18 mm Hg normally, and it also opposes the filtration. As we know that the capillaries are impermeable to plasma proteins, so there is no plasma proteins in the Bowman's capsule. So the Bowman's capsule colloid osmotic pressure is normally zero. By summing up all these determinants, we will find that the net filtration pressure is as 60% is in the direction of filtration and 18 and 32 are opposing the filtration. So the net will be 10 plus 10 millimeter Hg filtration pressure, which will cause filtration of the plasma from glomerular capillary into the Bowman's capsule. And as you can see here, this is 16 minus 18 minus 32 is equal to 10 millimeter Hg. This is the normal net filtration pressure. Multiplying the net filtration pressure with KFR, we will find the value of GFR. The normal GFR is 125 milliliter per minute or 180 liter per day, which is very large as compared to the normal quantity of fluid present in the body. This means that the fluid present in the body filters about 6 to 7 times a day. Here are the determinants. So as we have discussed earlier, that increased glomerular capillary filtration coefficient increases the GFR. If we increase the KF, with the value of GFR will also increase. Normally KF is expressed per 100 grams of kidney weight. It averages about 4.2 milliliter per minute. If we increase this, the GFR will also increase. In chronic hypertension, there is increase in the thickness of capillary, which causes the reduce in hydraulic conductivity, which in turn causes reduced KF. As the KF reduces, the GFR also reduces. So this is the first determinant. Now we will move to the second determinant, the increased Bowman's capsule hydrostatic pressure. If the Bowman's capsule hydrostatic pressure increase, in some cases like urinary tract obstruction, which causes the urine passage to be difficult from the ureters into the urinary bladder. So in this case, the Bowman capsule hydrostatic pressure increases very rapidly, and this causes the opposing of the filtration. So the GFR will also decrease in this case. Increased glomerular capillary colloid osmotic pressure. If the glomerular capillary plasma protein concentration is increased due to some abnormalities, the GFR will also decrease because the plasma proteins will bind the water with itself, and less water will be available for the filtration. The plasma colloid osmotic pressure of is can be increased by two ways. First of all, by increasing the arterial plasma colloid osmotic pressure. It means that if the arteries which carry blood to the glomerular capillaries have more plasma colloid plasma proteins, there will be more plasma proteins in the capillaries as well, which is a simple phenomenon. The second is by the increasing the filtration fraction. It is a very interesting thing. If the filtration fraction increases, the filtration fraction increases, the more water will be lost, and the amount of proteins as compared to water will increase more. That's why the GFR will decrease in this way. The last and the most important, which is the primary means for physiological regulation of GFR, is glomerular capillary hydrostatic pressure. If the glomerular capillary hydrostatic pressure is more, GFR is more, and if it is less, GFR is less. It is a simple and direct phenomenon. And the hydrostatic pressure depends upon three things: arterial pressure, afferent arteriolar resistance, and efferent arteriolar resistance. Arterial pressure increase will cause increased hydraulic pressure and increase GFR. And the afferent arteriolar resistance and efferent arteriolar resistance have inverse phenomena. Afferent arteriolar resistance decreases GFR while efferent arteriolar resistance shows peculiar behavior. If efferent arteriolar behavior is moderate, it means that if the moderate resistance is present, it will increase the glomerular hydrostatic pressure and GFR will increase. But if the efferent arteriolar resistance is severe, there will be decrease in renal plasma flow, which will cause increase in plasma filtration fraction, which will cause increase in glomerular capillary colloid osmotic pressure, which eventually decreases the GFR. So these are the basic regulatory steps of determining GFR in the normal person. Thank you.